Hello everyone, thank you very much for joining me for this lesson 3 where we discuss JPA and Hibernate. If you're watching the event live, don't forget you have a live chat there so you can ask me the questions in the live chat. If you're watching the event recorded, you can always ask your questions in the comment section, and of course all of you remember to follow me on Twitter and on LinkedIn. So I'm gonna keep it short and I'm going to start by sharing my screen already so all of you can see. I'm gonna start again from what we discussed already in the first lesson, and remember that I told you how to connect to a database and how to create an entity manager, which is the minimum you need to do. And then of course opening a transaction, committing, rollbacking a transaction can also be one of the things we can add on a catch block here. But last time we discussed about a few of the operations you do with the context, and you remember that the entity manager, it's called the manager because it's the manager of the context. So whenever you create an entity manager and you do that by using an entity manager factory, you create a context. In that context you can add entity instances. Those will be the only instances your JPA implementation knows and works with, and always at the end of the transaction by default, if it's a commit of course and not a rollback, the context will be mirrored to the database. So I'm going to teach you a few new things today. First of all, I know I let you curious a lot about the properties here. For the moment we didn't use them, so you have only seen how to create the connection to a database, obtaining this way an entity manager factory that you can use to get as many entity managers as you need. Usually there will be an entity manager per each use case. Normally we don't have a use cases here, we are just discussing technically how JPA works, but normally you would have multiple entity managers, no? But we always had these properties here that for the moment I just added as an empty maps. That means I didn't use any property, but today I will teach you two properties which are most likely the most important properties you use with JPA implementations. The properties you use, they are they depend on what implementation you use, so they are not agnostic to the implementation. So the properties I'm going to use now are specific to Hibernate. Depending on the JPA implementation you use, you might need to use different properties, or you might not even have similar properties. So be careful when we use specific properties. We use them according to the JPA implementation. Remember, JPA is a specification and you have multiple implementations to choose from, and we decided to use Hibernate because it's the most used, but it doesn't mean that you always use only Hibernate. So maybe the most important, oh sorry for that, my keyboard is in a different language. Okay, so maybe the most important you want to know, and you will use a lot during debugging sessions, is the show SQL property. So Hibernate show SQL, and remember, please do remember this property is very useful because from now on when we work with the operations, last time I told you, hey, this is why this happens, and I didn't want to focus on the SQL because I wanted you to remember, and I think I made a good job allowing you remember that we work with the context, but in the end we also need to know and understand that at the end of the transaction the context is mirrored through SQL queries. So that means at the end there will be, and not necessarily only at the end, but it can be during the transaction, for example if you have finds, but during say the work with the context, there will be now and then queries which will be sent to the DBMS, and that's how the JPA implementation works. In the end, with the data, it's just that you have to decouple a bit, and remember that the SQL queries are not necessarily sent together with the operation. So when I issue a remove, for example, which we discussed, that is marking the entity in the context for removal, this will issue a delete, but it will not issue the delete at the moment of calling the remove. It will be probably later, either when the commit happens or when you have a flush operations of operational context. So that's what you need to, first of all, change your mind into thinking in an ORM way, but at the same time remember that we do work with queries. And at some point someone told me, hey, we use Hibernate because you don't want to learn SQL anymore. This is totally wrong. So to really work well with an ORM framework such as Hibernate, but any other framework that operates with persistent context, which is a relational database, you need to first of all make sure that you learn very well SQL. The better you know how to use SQL, the best is for you, because you will understand better when maybe your framework does something that is wrong behind the scenes. Okay, so with that being said, why is it important to know you can enable these properties? Because you will be able this way to know what happens behind the scenes. The second property that I will teach you is a property that you should only use with examples and tutorials and never use with real-world applications. It is a property you can use to allow Hibernate to manipulate the database structure behind the scenes for you according to the changes you do on the model, so the Java classes. So you see, I have reused the employee class here, and yeah, maybe it doesn't really matter, employees. I have no table now, so it's only an empty database. Okay, see, nothing here, there is no table. I only defined the entity, so you have the ID, you can see the ID is marked with the ID column. As I told you, it's mandatory. I've used here the column annotation, you know, it's not essential unless the name differs. The table annotation, getters and setters, and then here what I will do now, it's in the properties, I'm gonna put the Hibernate, I think it was HBM2DDL. DDL is database description language, and then I need to specify what I expect, and there are a few operations I can expect here. By default, this is none. So by default, you don't expect anything to happen, which is the way, again, this is how you should have it in production. In production, we never use this capability from Hibernate. In production, it's risky to do that because you don't know what Hibernate does behind the scenes, and you don't want to be in a situation where you, for example, drop a column by mistake. Whenever you work with the database structure in a real-world application, you should always do it with version scripts. There are dependencies such as Flyway or Liquibase that you can use to easily version your database. You always have to know which are the scripts that have been run. This way you can create reverse scripts, so in case you want to have possibility to roll back, for example, a deployment, which is something really important with real-world applications. You need to know exactly what is the script. You need to have the possibility to create a rollback script. That doesn't work with the auto HBM to DDL feature from Hibernate. But when you use it with tutorials, like you saw me in the first and in the second lesson, I created myself the table and then I wrote the script, which is totally fine. And in a real world app, you would have to create it, even created a script, not created from the UI of Workbench or whatever you use, depending on your database. But with examples, we want to save as much time as possible. No, and this is a property that I will use from now on, because when I will have more than one entity, I would have to create those tables myself, and I don't want to spend the time to write or create the tables. I will assume you know how to do that, and I will allow Hibernate do that for me, but that only works with examples to save time. So no something like that in a real world application. Thank you. I also say hello, guys. I'm happy to see you are here from around the world. Hola Mexico, hi India, hi Pakistan. So thank you very much for being here with me. So if you have any comments or questions, remember you can put them in the live chat and afterwards in the comment section. With that being said, let's see what happens with this. I'm very curious. If I'm running my application now, it's nothing in, oh, sorry for that. It's nothing here in the transaction. You see, it's only my comments from last time. Nothing happens now. So the only thing I expect to happen is, because I have an employee, the table should be created. So I'm not sure exactly why it asks me to run it like this, but anyway, so I should see that the console shows, and besides the usual comments that we have now, the usual logs, we should see also two queries, which is one of them. Because of this create here, what happens is that Hibernate will drop my employees table if it exists, and then we will create a new one every time. So that's what this create does here. It's very important in examples, because it always allows you to do things from the very start, from clean. So you delete everything, recreate. If you don't want that, you can use the update. So now let's see. I showed you that I've shown you that you have the drop and the create. So theoretically, we may assume that the table has been created. You can see the employees table has been created according to what we wanted. Hello, Finland. And you also see that if I can try that. So if I put manually some data here, address and name, and then apply. So I'm wanna select again to make sure it stays here. And now I have create again. No, if I run the app again, that addition I made, that record should disappear normally, because if I have create, then it would basically drop the table, as you can see, and then create it again. So these are the queries that Hibernate run, and we can see them because of this property that we have used here. And then when I'm going here back and I'm selecting it, it's again empty, okay? Because create does that. If you don't want that, if you want to continue your example, what you can do is move this to update. And if you move it to update, so you have create, none, and update. If you move it to update, then it will only create the table. If it doesn't exist, it should not drop it anymore, and it should only update it if it's needed. So let me see what happens. So I'm running it again, and we see nothing happen. No, not yet. Nothing happens because we already have the table. Okay, so there is no create table sent anymore. There is no drop. So depending on what you want, you might decide to do one or another. Okay, so this is very important. Now the first one, the first property here is important because you will see all the queries that happen. So one of the things that I want to discuss today, because we didn't go yet through all the operations with the context, I want to start with find versus get reference. We already used find. You know what it does actually. You know that it's used to get by the primary key value from the database and grab an empty instance to the context. So you can say something like employee entity manager find, employee class 1, and if I try this now, of course my table is empty, so I should see nothing, it should be null, but we should actually see anyway that at least the query happens. So I can print it, this will be null because you don't have anything here, but I think we should see the query, no? And then we will also add an employee. You already know how to do that. We will use a persist for that. And here it is. So you see the query, the select query, and of course there is nothing in the database, so the result is null. Now what happens if I'm creating an employee? So I'm actually saying var e1 new employee, e1 set id 1, set name or address, and set name to John. And then find it afterwards. If I use the persist operation, so I expect this adds the entity to the context, and then what will happen is that the find will actually find the entity in the context, depending on the implementation. If it might happen that the persist happens before or after, but now this is something. This is where we don't really care about it, no, because again, when working with a context-based framework, we rely on what happens behind the scenes, but we accept the fact that we don't know exactly which are the queries and in which order they will be sent. We accept just that the result will be the expected one. So you see, in this case, there is no select query, so we can easily explain why there is no select query, because we have added this to the context, and find will first search in the context. If it already finds the right entity in the context, it will not issue anymore in something to the database, because it doesn't need to. There is already in the that is already in the context, no? So you see, however, that the insert happened at the end. And the employee has been printed here, but the insert happened after we printed that, which is no longer null, of course. So this is our print here on line 38, and this query actually happened from somewhere from here when the commit of the transaction happened. No, but because again the persist is not sending an insert as you might think if you think in a JDBC way of working. When you work with a JPA implementation, you have to have an ORM way of thinking. So the reason these two are maybe in an opposite direction than you would expect, you might expect, hey, why is not the insert here and then the print of the employee? No, why are they the other way around? Is because the persist doesn't issue the insert here. The persist only makes sure this is added to the context, then find it in the context. Again, that's the reason why you don't see any select send to the database, and then at the commit here the insert happens again. Okay, and you can of course after that see that the data has been properly added as expected to the database. Now I'm gonna delete this, and I'm gonna demonstrate something that you need to know, which is how find works versus get reference. So the thing we want to discuss now is find versus get reference. Can we also add these properties from get properties of custom persistence class? That could be a possibility that I don't know. Again, I don't know basically absolutely all the details of this framework. So normally the only way I have used them by now is either putting them like this when I create a factory, or putting them in the persistence XML file. If we use, now we don't use a persistence XML file, but in the first lesson I told you that there are two possibilities. You have two possibilities to create the factory. It's either through a persistence XML file or from the persistence unit info. So in case you use a persistence XML file, you can add these properties there. Now, if there is such as a custom persistence class and a different way of doing that, I have to review that. It's not something I have used, okay? Now, going back to our find, so I'm gonna cut this out, and the only thing I'm leaving here is the find. What do you think will happen? I'll tell you what will happen. You will always see, when I run this example, you will always see a select query happening, okay? Let's do that. Let's try this multiple times. So we look in the console, okay? And we expect to see a select query. Is that select query that, of course, tries to find by ID the entity, and of course, if that's found, an instance of the entity will be added to the context. Of course, one of the things that I didn't discuss, but you probably observed, is the strange way these variables are named here. This is expected. This is this kind of automatic query creation uses this kind of strange names that are created by the framework. It's easy to see this way when a query is created, it's automatically created by the framework, because it will always have this strange way of naming, aliasing different tables or different stuff. So you see E1_0, in this case the alias for employees, which has been chosen by Hibernate. So it looks strange, but it works. In case you copy this here and you try it, you should have the same result. Of course, in my case here, I don't have a database selected, so that's why it's complaining, but it's working. So that's how it works. Good. Now again, you can try this as many times as you want. You will always have a query sent to the database, okay? But when I will change this find to get reference, that will not happen anymore. So you see, for find you always had this. Let's see what happens when you run the get reference. So no query has been sent. Now you see there is the process finished, the log appears here, but unlike the previous execution where I used find, there is no query. However, this will change if I do anything with the employee. So for example, what if I try to simply print it in the console? So when I do that and run it again, the query will magically appear. The difference between find and get reference is that with get reference, you only get a shell of the entity and no query is issued to the database. The query will, however, be issued once you do anything with that entity. So how does this happen? Actually, it's based on a decorator pattern. Get reference sends you actually a shell, which is a decorator over the entity. But it only creates the shell, ready to issue a query whenever that's needed. So it somehow lazily allows you to get the data from the database if there is no data yet in the context, only when that instance is really used by someone. So if you expect that something might, for some reason, might not be used, and you want to somehow save some time, some execution time, by not querying the database when that specific entity is not used, then you can use get reference. And instead of issuing anything, it will simply just create a shell, and no query will happen unless anything happens to that specific shell. Whenever you use that, and when I say use, I mean whatever you do with that specific entity, then of course it will have to issue the query to the database because the information is needed. But that will happen only when you practically use that specific entity. If you don't use it, the query will never be sent. So these are the difference between find and get reference. Good to keep them in mind. Depending on what you do, you might want to use one or another. Of course, using one or another makes sense and improves anything only depending on the case. But if you know that in your case, get reference would be a better approach, because there are maybe you query some entities, but you know that only part of them will be really used for some reason. I don't know, that's the algorithm. Let's just assume that. It's very difficult in theoretical examples to be sure about all the aspects. Okay, we just assume that. I don't comment if that's a scenario that may be a bad design or something. Maybe it is. It's just now how get reference and find works. Okay, so maybe you are in that case and you want to somehow improve the performance. You might want to use get reference because you don't want to use, to say you have 100 objects but only one of them for some reason will be used. Then in that case you might want to use the get reference because you don't want to issue 100 queries to a database if in reality only one of that collection of objects will be used. So essential to remember find versus get reference. Then of course we didn't discuss the refresh, so let's discuss refresh now. I still have this get reference or find, and then you know what happens when I change something. Remember, there is no such thing as an update operation on the context. Any change in the data of the context being entities that have been added in the context, either because they were taken through find, get reference, persisted, or maybe merged, as we discussed in the previous lesson. As long as the entity is in the context, you change something on it, like the name in my case, the change will be mirrored to the database by default when the commit happens. So in my case here, if my employee is named John, but I change the name to Anne and E1 is in the context, then we are sure that this change will be reflected in the database. When the commit happens, Hibernate will take a look at the context, we'll see which are the changes, and we'll mirror them to the database. So the name of my employee should become Anne instead of John. So when I'm going here, John has been replaced by Anne. Now let's say that we have this specific case. I at some point am not sure because I have a complex algorithm implemented, and I'm afraid that somewhere, somehow in my algorithm, someone might have changed something on my entity, and I know what will happen in that case. If someone changed anything, like the name here, then when the transaction is going to commit, like we have just seen, the name will also change in the database. Let's say that's something I don't want. So how can I make sure that on this line that my employee has not been previously changed? That's not something I can do easily without using the context. Fortunately for us, the context has this refresh method. So what you can do is refresh the object. So if you refresh the object here, another query will be sent to the database, and the current entity will be replaced by what exists in the database. The refresh is somehow an opposite maybe to persist, not really, or to update, is just taking the data the way it is now and replacing what you have with that data, such that if anyone changed it previously, it will become again as it was at the beginning of the context. So refresh is an undo of any change you have done in the context, such that you are sure that if after this line and before the commit there will be no other change, then there will be no change in the database. Remember, name is Anne. We changed it to Daniel, but we refreshed afterwards, so I expect it will become again Anne. And even if I'm printing out this after, before and after, we should see that initially we changed this to Daniel. However, after refreshing the context, it became again Anne, and then of course in the database we will see there is no change. So I'm running this again, and we'll take a look at the queries and the system outs, and then we'll take a look in the database. So the query has been issued to take the employee by ID, and the employee found is Anne. Before the refresh, we changed it to Daniel, but then we refreshed and another query has been sent and changed back to the initial data. So after the refresh, the name becomes again Anne, which is the initial name. So there is no change to Daniel in the database, because at the end, on this entity, there is no change that can be mirrored to a database. What if we change address and name in context? Now we need only reference or only refresh on name. Well, I'm not sure that's something you can actually do. So with normal refresh, from what I know, there is no, I'm not sure if this map does something. I've never used it, but I will check. But you usually use refresh when you want to refresh an entity, and I'm kind of strange, but I can understand your point of view, but it's kind of strange to try to partially refresh. I think you can do something like that. I will check out if there is something in the specification that can do partial refresh. I don't know that. I can't say it isn't because I'm not 100% sure. But it's nothing I know now. Okay. But I will check it out and let you know in the next lesson. Thank you very much for the question. Okay, and that basically concludes all the operations, because in the previous lesson we discussed persist, find. Today we discussed find and get reference. Last time we discussed detached. Now we discussed refresh, and we discussed merge as well. So these are basically the operations with the context. So throughout lesson 2 and 3 we managed to go through all this. Now we still have time, so I told you how to print the queries that you see, and I also told you how to create, if you want to always create, and again only with tutorials. Okay, never use this in real world apps. In real world apps you need to be very sure what queries are sent, so you can't use this with real world apps, but with tutorials is very effective. And there are a few things that I want to discuss with you in this part of lesson 3 that we still have, and I'd like to start by the ID generation. So first of all, when you just mark the ID, you expect that you have to provide values for the ID. So when I created my employee entity, you saw I had to fill in for the ID. I had to fill in something for the ID. However, you can use automatic generation of the ID, and to do that you have an annotation called generated value. So there are a couple of ways. I will now discuss only about the strategy. Next time maybe I will discuss about what a generator is, which is let's say a customizable possibility of creating an automatic generation of the IDs. Let's take first the simple approach with the strategy, which is basically also one of the, say, most used. I'm not sure how often you need to use nowadays a generator, but I will teach you how to do that as well. But let's assume that you want to use simply an existing strategy. So with the latest JPA, you are provided with 4 different strategies. If you use this auto constant, it will rely on the default of the implementation. So for example, Hibernate in my case, but it's not recommended you use auto. You should always specify explicitly what is the generation type that you expect. And there are 4 generation types here that I will explain. One of them is the identity. Mind that not all the generation strategies work with all the databases. So for example, identity, which is the first one I'd like to start with, is something applicable with MySQL as well, and is a way in which you allow the DBMS generate the IDs for you incrementally. In MySQL language, this is called an auto increment. So if I'm running the application now, let's assume I'm running now the application, we will be able to see the create table again, the create table DDL, and we should see that the create table has been created using auto increment. Yes, entity not found because I have used the create here. So you remember what happens, it drops the table, so automatically my employee has been removed as well when the table was dropped. So it's normal that we now see that employee with ID 1 doesn't any longer exist. So that's something expected. Now the table is empty, so it's normal we get this this exception here. But we are not interested in this exception now. So what we are interested in is this create, where you can see that the auto increment has been added at the declaration of the table on the ID. So what does that mean? It means that if I create a new employee and persist it, I will not need to specify anymore the ID. The ID will be automatically generated every time. So when I'm running now the application, oh, sorry, I forgot the persist. Sorry for that. I will do that again. So every time now I'm running the application, a new employee will add it, and the ID will incrementally grow. So if I'm running it now, the table initially was empty, and then when after the app runs, when I'm running the query again, what we should see is that an employee with the ID 1 will be added. So let's see. Okay, we see that an insert has been added. You can observe that the ID is not sent at all through the insert. That's not needed because the ID has been auto increment. So that means that the ID will be initially 1 for the first. And now what I'm gonna do is I'm gonna put this back to update because I don't want it to drop again my table. I want to keep the table with the employee. And when I will see then the second employee, I will see will have the ID 2. And then the third employee will have ID 3, and so on and so forth. Okay, so see, I'm running it again. An insert has been sent with no ID, but automatically the ID, hey, that's strange. That's strange because I didn't set any, did I set any uniqueness? I thought I didn't set any uniqueness, no? So I would expect to see 2 employees here. Oh, it was just a workbench problem, sorry. It was probably a cache on workbench, yeah. 2 employees, so ID 1, ID 2, okay? Makes sense, yeah. And then I'm running it again, and the next one will have the ID 3 and so on and so forth, okay? Exactly as I was explaining. Okay, so we see the insert, go back to workbench, and the third one appeared. So you can do that as many times as you'd like, okay? And this is basically because the table now has this property. This, I'm not sure exactly where can I see it here, if I can see it somewhere. But you have seen it in the create table, now table inspector. You have seen that the column is auto increment. See, you can see it here. So that's the first auto increment strategy, a very often used one. So the identity means allowing the DBMS give you incrementally IDs. Again, it doesn't work with all the DBMSs, so you have to make sure that the technology you use allows this identity. So for example, out of my knowledge, because I'm not an expert in all the databases, but Oracle, if I correctly recall, at some point didn't have this identity. I'm not sure it has it now or not, but it used not to have the identity. So if you use the identity with Oracle, it would have actually fall back to sequence, which again, if I correctly recall, my SQL doesn't have sequences. So if I do that now, it will automatically actually go to the table. So let's start with the table first. So instead of going to sequence, we were using identity. Let's see how the table strategy works. So I'm gonna move this to create again, so we have the table freshly created, and you will see that if I use the table strategy, there will be not only the employees table created, but a second table as well, and that's a table where the identifiers will be created. So let's see, a drop has been issued for employees, but another drop has been issued for a table that's named Hibernate sequences. Where does this Hibernate sequences come from? Well, it comes from Hibernate logic, of course. The table strategy that we want to use here, what it actually does, it relies on this table, which is by default named Hibernate sequences, to generate the IDs. So always the last value of the ID is stored in this table, so any new thing that you add will be added based on the last value of the ID, which is stored in this table. Both tables have been created, and then you see that by default it inserts a record in the Hibernate sequences starting with value 0. And then if I want to insert anything, it will be inserted based on the last value of the Hibernate sequences table. So to choose the ID, okay, which has been now sent through the query, first what Hibernate did is it selected the last value from this table. It also, you can observe, it used the for update reference here, which adds a lock on this table to make sure that if other queries at the same time try to change the table, they will be blocked. So it uses pessimistic locks for that, in other words. And then of course it also updates the sequence in the transaction to another value. So if I'm going now to check what happened here, I'm going to refresh again the tables. I should see two tables. One of them is the employees, the second one is the Hibernate sequences. In the employees, I will have the record. In the Hibernate sequences, I will see that the next value for the sequence name default, which is what Hibernate will use, is 50. So it doesn't you can do that, you can configure it to go it one by one, but usually it's best if you configure it like with a step of multiple values, such that if you have multiple transactions at the same time, they can already select the next one, and basically this way you can improve a bit the performance. Using such a table for generating the sequences is not really recommended. I would say it's probably the worst generation strategy you could use from a performance point of view, but this strategy can be used with literally any relational database. Not all the databases accept auto-incremented values, as I said. Not all the databases have sequences, but absolutely all the relational databases have tables. So that's why using this strategy works with absolutely any kind of relational database. But in terms of performance, is probably the worst you could use. Okay, so that's the table. Now the table is this one, and then let's say that I want to use sequence. So, and by the way, it's the generate value strategy and generator. Okay, so next time when we discuss about the generator, I will tell you how to create a custom generator, but it's not the time now. Let's go through, try to go through all of this. So the next one is sequence. Sequence is a very good to use strategy with databases that allow sequences. Sequences are entities at the database level that allow you to generate values in a specific by a specific logic. Usually you have an incremental sequence of numbers. Databases, engines, many have this kind of sequences. Oracle, for example, is one of them. Again, if I correctly recall, MySQL doesn't have it. I might be wrong, but at least in the earlier times, when I was using sequence, if I was using sequence with MySQL, it would automatically fall back to table. So that's why now if I'm gonna run this again, what we might see is that even if we changed this to sequence, it will still use a table for generating the values, because it falls back to a table. Okay. See, it just creates the table with a different name, and it relies on that. But normally it shouldn't be a table. Normally it should be a sequence. And if you use a database that supports sequences, it will not use a table, but it will really use a sequence. Try that with Oracle and you will see that. Again, when you choose, and I'm gonna drop this, all of them. When you choose a strategy for generating the values, please remember you always have to choose them according to the technology you use. So if you want, because you want to take the best out of it in terms of performance, no? So for example, with MySQL, it's okay to use the identity, but if I would use Oracle, I would choose to use sequence, for example. And using a generator, you can even specify what sequence and how to work with a specific sequence, and I will teach you next time when we deal more with customizations. I would probably never use the table. I'm showing this to you because I want you to know about it. It's essential to know everything about the framework, or as much as you can about the frameworks that you are using, but you should always know when not to use something. So I would suggest you not to use the table. And then the last one is the UUID, which is quite a new one. So this comes with the latest Jakarta JPA version. So it used not to exist, if you will. say, for example, take a look at older videos I have on this channel, you might see that this doesn't exist because at that time it didn't exist, and to create unique identifiers you would have had to use a custom generator like I will show you in the next lesson. But now things are a lot easier because this UUID exists. Of course, you can use an UUID type for that. I will regenerate the getter and the setter, and normally this will create me an ID with using universally unique identifiers instead of numbers. Universally unique identifiers are useful for IDs. But again, you should also use them smartly. So it created as a blob. I'm not sure if I can see here what is inside. Maybe because I used the UUID type. So this is the only way it seems I can see the value. Maybe I should have actually used string instead to make it easier. Let me see if I can do that. I normally prefer working with UUIDs, the type, but oh, sorry for that. Generate this again. Oh. So let's see what happens. And I was saying UUIDs for IDs are useful, but you have to take care because being binary or string data, depending on how you store it, the problem is that with specific, look, this is how it looks like. This is a standard universally unique identifier. If you don't know what an UUID is, just search on the internet. You will find good descriptions about how UUIDs are, but how the name suggests, a universally unique identifier is a value that is universally unique. Okay, and this is how it looks like, but I'm pretty sure most of you already know what an UUID is and how it looks like. Anyway, remember that they are not necessarily very good with performance, because in the indexing on string values is not very good with most databases. I'm not necessarily an expert with databases, but that's one thing that I've learned in the past. I've learned that if I use an UUID, some specific databases have specific types, like have specific universal unique identifier types that you should use to improve the performance. So don't use them as string. It's still not as good as numbers, but it's not as bad as using strings. So depending on the database type you use, make sure that you use the appropriate type. But the universal unique identifiers, they are sometimes useful because they offer you a very large field of values. So okay, even with numbers, no, if you have very large data sets, even with like very large numbers might not be enough for you. That's one point. Numbers have a limited spectrum. Universal unique identifiers don't have. So if you have something like, I don't know, banking transactions or something like that, you might want to use something that allows you not to overflow the value. Secondly, I do prefer to use universally unique identifiers when I have anything that will go to a front end. So imagine you have an endpoint that updates or selects something, selects some data, an entity from the database. If you use something like employee/1, someone might figure out that they can replace the one with 2 and then they get another employee detail. And if you haven't correctly implemented your security implementation at the application level, then you might leak information. It's best when you use with the front end something, never to use values that can be anticipated, like numbers. Like someone can just go and try, hey, what happens if I put a 10 here? No? That's a little bit more difficult with universal unique identifiers, because it's very unlikely you will guess. Okay? Try not to use with the front end guessable values. If you use universal unique identifiers with the front end, they are not easy to guess. So that adds a little bit more security to your application. In most cases, however, if I don't necessarily need to use universal unique identifiers as IDs, I use both a number value that is easy to index, and I also use a unique identifier separately. So I have an internal ID and an external ID. And the reason is I use the internal ID to put the indexing and the search, because that makes the app performant. And I use the external ID to work with the front end, because that adds a little bit of layer of security to my application. So that's basically it with UUIDs. And our time is basically almost up, but I'm happy to have been able to discuss today about to finish with all the operations on the context. I told you about how these two work, and we will use them a lot from now on. And then we discussed about how to generate values, and I told you about the 4 generation strategies and how to use them. In the next lesson, we will discuss a little bit more on generating values, and then we will go into a few essential annotations such as embedded, embeddable, attribute override, and afterwards we will go into relationships. I'm gonna end it here for today. I'm very happy again to have seen a lot of you and to say hi to everyone. And until next time we meet, have an excellent time for study further. Cheers, everyone.